All right, here's a straightforward, uncomplicated icebox problem. So we have F2 plus I2 yields 2 moles of iodine monofluoride. And so if initially we begin with 0.20 molar F2 and I2 and 0 of the product, what will the equilibrium concentrations be if KEQ equals 0.00872? So we know that it has to shift towards the products because there are no products and there are reactants present. So initially we have 0.20 molar, 0.20 molar, and 0 of the iodine monofluoride. What change is going to have to occur? Well, since there is no product and there is some of the reactant, we are going to lose X amount. And since these react in the same ratio, we will lose X amount from iodine as well. And as we do that, we will gain 2X on the iodine monofluoride. So then at equilibrium, we would have the initial minus X amount, so 0.20 minus X, 0.20 minus X, and 0 plus 2X, so it would be positive 2X there for the iodine monofluoride. And then we will take those and we'll plug them into an equilibrium expression. So we know that KEQ is going to equal the concentration of the product, and it is going to get squared over the concentration of fluorine times the concentration of iodine. Then we will plug into this equilibrium expression our KEQ and our equilibrium values. So then we're going to have 0.00872 equals 2X squared over 0.20 minus X times 0.20 minus X. But since 0.20 minus X times 0.20 minus X, since those are the same terms, we can simplify that into zero point zero, or I'm sorry, 0.20 minus X squared. That makes the math a little bit prettier because then I can take the square root of both sides to isolate it. I'm going to bring that down here. So then we have whatever the square root of 0.00872 is. So 0.0934 is going to equal 2X over 0.20 minus X. We will multiply the 0.20 minus X over to this side, giving us 0.0187 minus 0.0934x equals 2x. Then add the 0.0934 back to the other side. So that would leave us with 0.0187 equals 2.0934x. Divide the 2.0934 back to there, and x ends up equaling 0.0089. Feels like we picked up a 0 somewhere. 0.0187. So then that x is not our answer. We have to plug this x back into our equilibrium expressions. Or our equilibrium values. So at equilibrium, we would have 0.20 minus that number and then rounded to 2 sig figs is going to get us 0.19 molar, 0.19 molar, and 2 times that guy is going to be 0.018 molar. And those would be our answers.